Hello and welcome to this video on how Unreal Engine can be used to create pre-production documentation for creative projects. My name is Daniel Haynes and I am a technical specialist at University of Staffordshire and an Unreal authorised instructor at the silver level. In this video I'm going to be covering various ways through which Unreal Engine can be used to enhance the pre-production process through 4 key areas: storyboards, floor plans, measurements, and level snapshots. For those that may not be fully aware, the pre-production process for creative projects includes a large quantity of documentation that aims to make the actual production run smoother. This can take many forms, from storyboards to shot lists and from floor plans to previs videos. Pre-production is a vital stage of the process and can easily be overlooked due to the complexities associated with it. But hopefully, after watching this video, you will feel confident in using Unreal Engine to assist you with your pre-production work. In this video, I'm going to be using Unreal Engine 5.6 and the stylized Egypt environment created by Alexander Ivanov, which you can get for yourself on the Fab Store. If you already have a project ready that you want to use, that's great. You'll be able to follow along with no issues. If you haven't got that stylized Egypt environment, then navigate to the Fab Store within the Epic Games launcher or by going to fab.com and add the pack to your library. Then click Add to Project within the Epic Games Store library. Alternatively, if you're already within Unreal Engine, you can click the Fab button and search for Stylized Egypt within there. In your project's content browser, navigate to Stylized Egypt and then Maps and double-click on the Stylized Egypt demo level. I find that Unreal Engine is a great tool for creating accurate images for storyboards, due to how easy it can be to iterate through shots and get high quality exported images. On the left of your screen, you can see the storyboard images I created within Unreal Engine for our short film Drifting, with the final shot from the film on the right. As you can see, the storyboard images line up incredibly well against the final product, minus some small changes in angles here and there. Thanks to these storyboards, I was able to create a full rough edit of the film before we stepped into the studio, saving us valuable time on our shoot day. To keep things simple, the only things I use to create these images are a cine camera actor, the third-person content pack, and the high-res shot console command. So let's get started. Firstly, I'm going to find an interesting section within this map that I want to be the background of my shot. Next, I'm going to bring in a cine camera actor by dragging one in from the Place Actor panel into my viewport. A cine camera actor has additional settings than the base camera actor within Unreal Engine 5, such as film back and lens. With the cine camera actor, we can mimic our physical camera with a virtual camera inside of Unreal Engine. So anything we create within Unreal Engine can be replicated with our physical setup. Now we have our cine camera actor within our environment, we need to give it settings that replicate our physical camera, which for me is a Blackmagic Ursa Mini Pro 12K. By selecting the cine camera actor within the outliner and going to the details pane, I can scroll down to the film back section and set the following settings. I'll be setting my sensor width to 27.03mm and my sensor height to 14.25mm. Now, it's worth being aware that the sensor width and height will change depending on the physical camera you are going to shoot on or the camera that you are trying to emulate. So make sure you research that, don't just use my settings, there'll be specific settings for the cameras you're going to use. As we've changed the sensor width and height, you may have noticed that the preview window for the cine camera actor has been changing shape. This preview window is in the same aspect ratio of the given sensor settings, so right now this preview window is in a 17:9 aspect ratio. If we want to change the aspect ratio of the camera, we can navigate to the crop settings, where we can change between no crop, defaults such as 4:3, 16:9 or 2.39:1, or even define a custom aspect ratio. For this project, I want my output to be in the 2.39:1 aspect ratio. We can pin the preview window to the viewport, so we can always see how it is affected by anything else we move or change within the environment by clicking the small pin icon on the bottom left of the preview window. Next, I need to set my lens settings. Now, these are going to be different based on the lens I have attached to my camera versus the lens that you have attached to yours. As part of our setup, we have 4 main lenses: a 24mm, 35mm, 50mm, and 85mm Mikey Prime lenses, and each of these lenses go from T2.1 to T22. Now, the Ursa 12K has a crop factor of 1.3 times, and as such I need to convert my Mikey lenses into their actual focal lengths for accuracy when composing my shots. So for my 24mm lens, that is actually going to be represented as 31.2mm. My 35mm lens is going to be represented as 45.5mm. My 50mm is going to be 65mm, and finally my 85mm lens will be represented as 110.5mm. I highly recommend making a note of your available lenses and their actual focal lengths after crop factor is deduced. This will make it easier to input your various lens information later. Another important note is that Unreal Engine works with f-stops and not t-stops, and they recommend that you convert your lens from t-stop to f-stop when entering aperture values. There are details online of how to do this, but for a large percentage of users you should be able to get away with inputting the t-stop value as the f-stop. It won't be completely accurate, but outside of lengthy and confusing conversion processes, I personally believe that is the best option. So with our focal length and aperture values attained, we now need to add these on to the Cine Camera Actor. In the detail panel are 4 values we need to set: the minimum focal length, the maximum focal length, the minimum f-stop, and the maximum f-stop. So for the minimum focal length, my 24mm lens, which is the widest lens I have, when factoring in the crop factor of 1.3 times, becomes 31.2mm. And then on the other end of the scale, my maximum focal length for my 85mm lens is going to be 110.5mm when taking into account the crop factor. As mentioned earlier, all of my lenses go from a minimum t-stop value of 2.1 to a maximum t-stop value of 22. Further down in the current camera settings section, you need to set your current focal length and current aperture values accordingly. For the shot I'm going to create as part of this lesson, I'm going to go with an establishing shot and will be using my widest lens, which is my 24mm, and as such I'll be entering 31.2mm as my current focal length. For my shot, to get a nice balance between depth of field and focal clarity, I'm going to be recording at aperture 2.8, and I'll enter that into my current aperture field. This gives me a great baseline to work from, with my virtual camera matching my physical camera and lens. With all my camera settings correctly configured, I'm going to pilot my Cine Camera Actor to get it into position. While in the pilot view, any movement that I make within the viewport will automatically update the position of the Cine Camera Actor within the level. To pilot my camera, I'm going to change from perspective view along the toolbar settings at the top and change it to Cine Camera Actor. I think I like this view over here. Now that I've found a great shot angle, I'm going to eject from the Cine Camera Actor using the eject icon. The next step in creating my storyboard images is to bring in a subject of my shot. The simplest solution I found is to import the third-person content pack included in Unreal Engine by default and use the mannequin figures within it to stand in as our actors. To do this, click the plus Add button along the top of the content browser and select Add Feature or Content Pack. In the window that opens, select Third Person and then click Add to Project. Give it a moment to import and then close the Add Content to the project window. Now, in your content browser, you will have some new assets, and the ones that we are going to look at specifically can be found in the Content, Characters, Mannequins, Anims folder. This folder, which in itself is broken down into categorized subfolders, contains a variety of animations using the Mani mannequin. For now, I'm going to go into the unarmed folder and drag the mm_idle animation sequence into the level. With the animation sequence in my level, I can now look at the details panel to customize how it appears. As our storyboard images are going to be just that, an image, this means we can actually pick and choose which animation frame we want to use as part of the level. To change this, we simply modify the initial position setting, finding a frame that looks like our character is waiting around. Realistically, within this animation sequence, any frame will do. With an animation frame selected, we now need to place this mannequin within our shot. Firstly, I'm going to place him in the general vicinity of the shot location. Then I'm going to pilot my cine camera actor, select my mannequin again, and move it into the exact position that I require. The final step in the process before we export our storyboard images is to set the focus of the cine camera actor. By selecting the cine camera actor within the outliner, we can scroll down in the details panel and find manual focus distance under the focus settings. By clicking on the pipette, we can then click on the mannequin within our level, and Unreal Engine will automatically calculate the distance between the camera and the mannequin and set the focus distance automatically. At this stage, our shot is complete and ready for exporting, but one thing you may wish to do beforehand is to toggle gizmo visibility. Gizmos, if present within your shot, will appear on the exported image, and by default you can press G to toggle the visibility of decal, lighting, and other gizmos within your level. To export our image, we're going to firstly make sure that we are piloting our cine camera actor, and then go down to the console command area of Unreal Engine. In here, we are going to type high-res shot followed by a resolution. For a 4K image, I typically write high-res shot 3840x2160, which gives me an image 3840 pixels wide and the correct number of pixels in height to match the aspect ratio of the virtual camera. After entering this console command, the image is saved to the Saved Screenshots folder within your Unreal Engine project directory. What I like to then do is rename the file to give it specific information about the shot and camera. For example, I might rename this to Scene 1 Shot 1 24mm f2.8. This makes it easier down the line to refer back to the image. Furthermore, in the likely case of creating more storyboard images, I might choose to duplicate my cine camera actor and rename them rather than just moving the single camera. This means that I can revisit my camera positions later in the project if I need to double check any camera settings or change them due to modifications within the project. So how might you use these images? Well, for drifting, I used my storyboard images in two distinct ways. Firstly, as you might have guessed, I used the images to create my storyboards. Because I named my files in a descriptive manner, but also left my cine camera actors within my level, I could quickly check the specific camera settings, or even camera position and rotation, and this was incredibly useful for the cinematographer and the camera operator. Another way through which I made use of my images was when I created a very rough edit of my film before we'd filmed anything for the project. I got my two actors into a Teams call as part of the usual script read-through sessions. However, with their permission, I recorded that read-through. I then took this audio recording, put it into my editing software, and overlaid my storyboard images over the top. This allowed me to create a basic version of the entire project. I could check pacing, shot diversity and editing flow well before we got to set. I hope that this gives you an idea of other ways that you can make use of your images, They don't just have to be for storyboards. Next, let's talk about floor plans. Floor plans are a great way to visually demonstrate how your location will be set up on a shoot day, where lights will be placed, where your camera positions are, where your actors will be, and so on. In a similar vein to storyboard images, the higher quality that your base image is, the easier it is to visualize your set. I'm going to cover 3 methods of getting imagery suitable for floor plans. All 3 methods have benefits and drawbacks to them, so it's worth following along and seeing which method you feel meets your needs. The first method is also the simplest. For this, we're going to move our viewport camera directly above our environment and export a high-res shot that will output into our project's screenshot folder. Moving the camera around is a little bit tricky to make sure you're exactly over the area you need, but give it a few moments and make sure you get the right area within your viewport. One issue that we might have is that certain assets may block the camera from seeing the floor, for example, this tree. With this method, to remove unneeded assets, we simply need to find the actor within the outliner and then toggle its visibility with the eye icon. It's worth noting that all of these methods can still use the G key to toggle gizmo visibility. You may choose to leave your gizmos on so you can see anything within Unreal Engine that is affecting your scene, or you may choose to hide them so that you can draw in your camera and lighting positions yourself. So why should you use this method? Well, the main benefit of using the viewport camera is that this is by far the quickest method of getting a usable floor plan image. It's easy to reposition and it's easy to hide assets within the viewport, and you can choose whether to have gizmos displayed or not. On the other hand, the viewport camera is not a true top-down view. It is a perspective view and as such is not truly accurate. An image created this way would work nicely as a visual reference, but would not truly be usable for situations where accurate measurements need to be made. Moving on to the second option. We're going to use the top-down orthographic view within Unreal Engine and once again output a high-resolution screenshot. To change from our current camera mode, we can click where it says Perspective at the top of our viewport and change this to Top. An important note is that this will likely change your view mode from lit to wireframe. This can be easily changed back by clicking where it says wireframe at the top of the viewport tools and changing this back to lit. There are other ways of changing to top camera mode. The first is the keyboard shortcut Alt and J. Alternatively, you can hold the control button and click and drag using the middle mouse button in the viewport. This will create a line in the direction you dragged in. To get to top view, you need the line to move straight upwards, or north if you imagine it as a compass, and then let go of the buttons. To change back to the perspective camera mode, you'll want the line to be moving southeast, again if you were imagining it as a compass. Within this top view, we can move around by holding the right mouse button and moving around the space. We can also zoom in and out through the scroll wheel. An important note is that, unlike the viewport camera, this is a true orthographic view and as such can be relied upon for accurate measurements. If you need to move or hide objects within the viewport, you can do this the same way as you would with the first method, but as you may have noticed, the top orthographic view will cut away from objects that are in the way, although the settings of this can't be configured and it may end up cutting away things you may not wish for it to do so. As expected, we'll use the high-res shot command to output our image. So what are the drawbacks of using this method? Well, the main drawback with the top orthographic view is that you are unable to rotate it. You are locked to a specific view angle, which might mean that your map appears upside down, sideways, or at a really awkward angle. This is unfortunately a limitation within the top view. On the positive side, as I mentioned, it is a true top-down, measurable point of view. It is still easy to hide objects, and it is probably the easiest method to reposition. Now let's go through the final method I'm going to share in this video, and that is through using a camera actor with an orthographic view. To begin, drag a camera actor from your Place Actors panel. You may have to search for it in the search bar at the top. Note that this does specifically require a camera actor and not a cine camera actor, as that does not have the specific settings we require here. With your camera actor placed in your level, change the projection mode from perspective to orthographic, and then rotate the camera actor by -90 degrees in the Y-axis. This will make our camera point straight downwards. At this point, switch your view from the perspective viewport camera to piloting the camera actor itself. This allows us to see what we are changing with the orthographic camera. We can change the zoom level of the camera by changing the ortho width value. A smaller value narrows the view, whereas a larger value gives a larger, wider view. We can move this camera around by adjusting the X and Y positional values and rotate it with either the X or Z rotation axes. The largest benefit of using the camera actor with an orthographic projection mode is our ability to change what I call the slice level of the camera. What you may have noticed with the other methods is that if we wanted to hide an asset, we would either have to toggle its visibility within the outliner or be beholden to a cutaway level that we can't control in the case of the top view. While this is convenient, it can also lead to assets being fully removed where we only need to actually remove the top of them. For example, if I was creating a scene within this building and I wanted to create a floor plan image for it, I may have to toggle the visibility of the entire building, functionally making the floor plan useless. On the other hand, with my orthographic camera, I can change the Z position and this will almost cut out assets at certain heights within my level, allowing me to look inside of buildings without having to hide assets. For example, if I set my Z position of my camera to 2500, you can now see all the details of buildings surrounding my mannequin, which is useful for getting a great indication of where we are within the level. Now, if I bring my Z position down to around 1100, you can see it slicing away the higher parts of the surrounding buildings along with the top of the tree, all without interfering with my mannequin or having to hide assets. As you'd expect, you can also toggle your gizmo visibility in this view, making the orthographic camera a very versatile tool. To export my image, I can either export a high-resolution screenshot as with the other methods, or I can create a level sequence with the camera present within it and render out an image with higher quality than the base screenshot tool will allow. To do this, within your content browser, right-click, hover over the cinematics category and select Level Sequence. Give it a name and then open it. With the sequencer window open, drag your orthographic camera actor from the outliner into the sequencer. This may change it to wireframe view, so make sure you switch it to lit. Then, click the Render this movie to a video or image frame sequence button. In the window that opens, click where it says Unsaved Config. This opens up the export settings. Feel free to dive in and try out lots of the different functionality of the movie render queue to achieve higher quality, or you can leave it as it is. The main thing you need to change, however, is the custom end frame within the output tab. By default, it will export the entire duration of the level sequence, which may be hundreds of frames long. As we only need a single image for our floor plan, we can set the end frame to frame 1, so Unreal Engine only exports a single frame. With our settings correct, we can close this window and click Render Local to export our image. If you want to take a deeper dive into this, you can even use the Path Tracer functionality to boost the quality even further. To give you a visual representation of the different floor plan images, here are some images I took using an environment of mine. On the left hand side, you can see the viewport floor plan image. In the middle, you can see the top view floor plan image. And on the right hand side, you can see the camera actor with an orthographic view and the image that was created from that. The third pre-production tip I'm going to share is a quick one, and that is about measuring distances within Unreal Engine. I'm sure a lot of you have done it where you bring in a default cube and increased its scale to measure a gap, but there's actually an even easier way that's also much more accurate. We're going to head back into our top view, and while this also works within any of the different view modes, I'm actually going to change to a wireframe view. Then, by clicking in my middle mouse button and dragging my mouse around, Unreal Engine is going to create a line with a value measurement at the end of it. This line is affected by the current object grid snapping settings. So if I turn off my grid snap, this will allow me to measure the distance with high accuracy. Whereas if I turn on the grid snap and say set it to 100, it will read out in 100 value increments, which again may be useful depending on the purpose. It can also be difficult to accurately determine where objects start and end, and as such I use the grid functionality to be able to more accurately measure my assets. To make the grid visible behind my actors if it's not already, I'm going to select the actors I wish to remain visible, then right click and go to Visibility and select Show Only Selected. This will hide all other actors within my scene, and it will allow the grid to become visible below my environment. The grid also changes based on your current grid snap increment. So setting this to 10 will create a smaller grid, whereas setting it to 100 will create a larger grid. This is a good way of being able to tell larger distances with much more ease. Measuring objects this way also works within the other orthographic view modes such as left, right, front and back. You can change the units Unreal Engine uses to measure in if you go to Edit, Editor Preferences, Level Editor, and then Viewports. There is a Measuring Tool Units setting where you can choose which setting Unreal Engine will display measurements in. The final pre-production tool I want to share with you today utilizes Level Snapshots. Level Snapshots are a great way to be able to quickly bring up different versions of your level, especially useful in situations where you may be demonstrating your level to actors or other members of the production, and rather than making the changes live, you want to set them up beforehand. To get started with Level Snapshots, you'll firstly want to configure your level as desired for your first level snapshot. For example, I want to set up my level for a daytime shot, with my mannequin in this specific position and the camera in this position. I'm then going to click on the Create Level Snapshot button just above the viewport. I'm going to give it a name and a description and then click Create Level Snapshot. Next, I'm going to set up my environment for the next sequence, which may be set at dusk. As such, I'll change the position of my directional light. I might move my actor and I'll move my camera to match. Maybe now they're leaving one of these buildings. And again, as before, I'll create a level sequence with a name and a description. At this point, I can open the Level Snapshots editor window, which contains a list of all level snapshots I've created within this level. If I hover over a snapshot, I can see its name and description, which helps me identify which one I want to restore. If I double click on a level snapshot, it will populate the rightmost column, which provides a detailed list of actors that have been modified from the current version. I can then press the Restore Level Snapshot button to revert to this selected level snapshot. Now that I'm back in my original snapshot, I can look back at my Level Snapshot editor window and select my second snapshot. But this time I may have decided that I don't want to change the time of day, and as such I can untick any changes to my directional light source. If I then press Restore Level Snapshot, you can see how I've now got my second camera and actor position with my first shot's lighting setup. This level of flexibility makes Level Snapshots a great way to iterate through different shots that are part of your project, and a fantastic tool when showing off your work in the pre-production stage. It's also worth noting that if you're working on a virtual production project within Unreal Engine and Switchboard, you can actually restore level snapshots while your project is live, making changes between shots and environments even quicker. So this has been a video on how Unreal Engine can aid you in your pre-production efforts through creating images for storyboards and floor plans, accurately measuring distances, and through using level snapshots to quickly iterate through different versions of your project. I hope you found this video useful, and if you did, please let me know, along with any comments or feedback that you may have. If you have any tips you wish to share with other video viewers, please leave them down in the comments section. And above all else, thank you very much for watching.